Okay, so writing electronic configuration, how to write electronic configuration. So this is called as the off-bar diagram. Okay, so you have to quickly reproduce this whenever you are supposed to write an electronic configuration. Okay, you have to write 1s followed by 2s, 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 6d, 6s, 6p, 7s. You can write this in the form of a triangle. Okay, so it's easy. So the electron, the electron first goes to 1s followed by 2s, and then it goes to 2p, and then it goes to 3s, and then it goes to 3p, and then it goes to 4s, and then to 3d, and then to 4p, and then to 5s, and then to 3d, and then to 5p, and then to 6s, and then to 4f, 5d, to 6p, to 7s, like this. So what is the take home? The most important thing here is to know that all the s orbital, we know that all the s orbital, we know that they can hold only 2 electrons. All the p can hold only 6 electrons. All the d orbitals can hold only 10 electrons, and all the f orbitals can hold only 14 electrons. That we know. But the way in which the electrons are ordered, why we cannot go 1s followed by 2s. 1 to 2s is okay. 2s to 2p is also okay. From 3s and then to 3p. From 3p, it is not going to 3d, but it's going to 4s, because it is going in the order of increasing n plus L value. Okay, so the n plus L value, the increasing n plus L value is the increasing energy value. Okay, so this is increasing energy value. So it's not like directly increasing. So if you increase the n plus L value, if you look at from 1s to 2s, 2s to 2p, 2p to 3s, 3s to 3p is everything fine. But now look at the value between 3d, 4s and 3d. For 4s and 3d, the n plus L value, n value is 4 plus L value for S subshell is 0 is equal to 4. But here 3, for D, the value is 2. So it is going to be 5. So it is 4. So this is 4, but this is 5. That is the reason it goes to 4 and then to 5 and so on. So the n plus L value increases. So the electrons also occupy based on the energy levels. Okay, the higher the energy levels, they occupy later on. Okay, so that is the reason. So you have to reproduce this diagram as quickly as possible. Then only you can write this. Now if you write this, then the whole thing is rest of the writing electronic configuration is it's very easy. So neon is atomic number 10. So the first 2 electron goes here, 1s2. You just 1s2, 2s2, and then 2p6. So you write 1s2, 2s2, 2p6, and then you count them. 2 plus 2, 4, 4 plus 2, 6. So it's done. So this is the electronic configuration of neon. You just add this number to see whether you have done correctly. If you look at potassium, atomic number is 19. 1s2, 2s2, 2p6. So I have done 2 plus 2 plus 6 is 10. And then the next 2 electron is going to 3s, 2. So I have 3s2, and then I have 3p6. So this 2 plus 2 plus 6, 10. 12, 18. So 18 is done, but I have 19. After 3p, the electron is going to not go to 3d, but it's going to 4s. So 4s1. If it is calcium, that is 20, that's 1s2, 2s2, 2p6, 3s2, 3p6, simply 4s2. If it is zinc, 30, 1s2, 2s2, 2p6, 3s2, 3p6, and I know 4s2 is 20, and at 3d, how many electrons I can hold? 10. So 20 is done. I need 30. I'm going to write 3d 10. But these two elements, chromium and copper, atomic number 24 and 29, okay, if you go and check the electronic configuration, it's going to look like this: 1s2, 2s2, 2p6, 3s2, 3p6. We are supposed to write 4s2, 3d4. Okay, so because we have to put the two electron here, this is the correct way we should have written. But the electronic configuration, if you go to periodic table, it is not going to look like this. It is going to look like now it is going to be 4s1, 3d5. Just going to erase this. Four s1 and 3d5. So it is going to be exactly 2 plus 2 plus 6 plus 2, 18. 18 plus 6 is 20. Yes. Okay. So it's going to look like this because half-filled shells, because there is 10 electrons possible in D, of which it has 5 electrons. 2 electrons are possible in S. You have 1 electron. So if you have this, it is more stable compared to 4s2, 3d4. Okay. And the same thing happens here. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, it should be 3d9. But when you look at the periodic table, it is going to look like this. First erase this. It's going to be 4s1 and 3d10. So same thing, it's going to fill the entire d orbital and it's going to give the half to 4s. Okay, some anomalies are there in the periodic table. Okay, these two are anomalies. Okay, so the rest of them are going to be fine. So if you look at the chromium, the 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 elements below chromium and below copper are going to behave a little bit bizarre in the electronic configuration. Okay, so this is how you write electronic configuration. It's one of the most easiest thing as long as you you draw this off-bar diagram, then writing is very easy.